Okay, welcome all after the lunch. I'll try my best to keep you awake. So we have a short time, and being a faculty, always love to talk more. But I'll concentrate on three things mainly. First of all, what is the roadmap towards AI, where big data fits in? What are the things we are missing right now to get to the point in AI where we should be getting at? And then a couple of use cases which I have worked on so far. I'll try to introduce those to make it a little bit interesting. But last few years, majority of my work has been mostly on the governance and policy side, so my cases will be around that. Now, to start with, what is AI? In my language, this is pretty much what it is. AI is nothing but an output at the end of the day, provided, and how best your output is depends on two things. One is how best your input is, and that's where your data comes in, and how best you can analyze that input to get some intelligent insight. So the AI will be really scary if we can do these two things really, really well, which in my opinion, we are still far away, right? And just for all of you, AI is nothing new. It started back in 1950, right? The issue back then was that we didn't have a lot of things. So this is the chronology of how AI tried to move forward back from 1950 till 1970, when more or less the scientific community said, AI is just a bluff, nothing is coming out there because there has been no use cases could come out by then, mainly because of two things, right? So I'll come to that. So just wanted to get an idea that AI is nothing new. It's making a lot of noise because the things which we are missing back then in the 50s, 60s, 70s, some of those things we have now, right? So what has changed? Why again now? Well, the reason is as follows. All of a sudden, we have two things. We have large-scale computing power, although I am a little bit skeptical about that, and we have lots of data of different kinds. These are the two things which I call as here the input, which changed, and the ability of analytics, which gives the intelligent. That's why AI making a lot of noise now, okay? Now, here is the general flow. So for a successful AI or an output, the way I look at it, you need these things. You need big data. That's the first priority, which we know a lot about. We need predictive analytics. We know a little bit about it, not a lot. And a completely unknown territory, behavioral science, cognitive neuroscience, completely unknown territory, okay? And computing. So the only hope that when quantum computing comes, we'll get there. So these are the four pillars, in my opinion, needed to really do well in AI. We need to be able to have lots of data, different kind. We need to be able to have very good predictive analytics. We are still not there. And I'll come in a minute what I mean by that. Behavioral science is something picking up right now in combination with analytics. So for example, if I am figuring out about fraud analytics, now people have started realizing that in fraud analytics, it's not only data, it's also, can I differentiate the person who is doing the fraud, his walking style, his talking style, his voice modulation, are those different than the people who are not doing fraud, which is not in the data. So this behavioral science is becoming a very, very big thing coming days. I mean, you'll be amazed to know, nowadays Google, 1/3 of their analytics team are psychologists and economists, not techie guys. Mainly because they want to tap this behavioral angle in analytics, right? We don't know practically anything about it. Then the computing part. Very fast computation. We are extremely good right now, world over, including India, in storing data. No matter how big your data is, we are very good in storing. But we are still a long way in processing in a very faster way. So this is where it is. Now, as of now, what we do is something what we call weak artificial intelligence. Down the road, if all of this come together, we'll get to the strong AI. So weak AI is what we are seeing nowadays. Strong AI needs time, needs more research on these three pillars. Predictive analytics, behavioral science, and the computing needs to come together for the strong AI to really build on it. Okay? Now, let me just come quickly. What is big data and why this is one of the biggest pillars for AI to be successful? Okay? So, the first thing in big data is, all of us know this definition, so there is nothing great about it. But what is important is that we are going to produce more and more unstructured data. Are we have ability to absorb that as a data? Right, so you will see a lot of these chat box, a lot of these data robo companies coming up. But there is no data robo company which, if I look at the output and I can talk to the computer by saying, this variable is not making sense, change this variable. That's not happening. Right? So unless that happens, it's not becoming very seamless. Right? Now, in big data, the real issue is not so much of having too much data. It's a real issue of having data which you never thought they had data. To give an example, here is a big journal in management fraternity called Management Science. So this is the paper came out in 2017. So when we worked with this company's only suggestion was that how do you, without talking to my HR guys, can still figure out how my new employees are doing. Are they adapting well to the organization or they are feeling aloof? So we looked at their data. What data you look at? Very carefully you should look at the third bullet point. We tried to answer that question by using text analytics to the 10.24 million internal emails of the organization. Nothing else. This is what I mean by big data. This is what needs to be a vertical of AI, whatever you built in, right? Another company in Singapore came up and tried to ask that I'm going to make some changes in my company. I know there will be revolt. But if I can convince the most influential of my company, I think I'll be okay. Who are my most influential? All the data we put together are completely unstructured data, right? So these are the things what I mean by big data. Mobile analytics. These are the questions we ask in the class. Do you know where you will be from 25 days now at 2 p.m.? Companies are there who are tracking your mobile network, starting from, whenever you get up, your phone is on till you go to bed. There are companies in Atlanta called Mojian.com who has tied up with Starbucks by saying, whenever a person is going by my half a kilometer of my, cafe, pass on a advertisement, 20% off cappuccino. They have increased the sales by 22%, right? So all this is one aspect of big data. Another aspect of big data, which is really useful to me, is the proxy data, and which is where the policy guys comes in. I want to solve a problem, but I really don't want to do survey because survey is one shot. But I do not have data. How do I answer that problem? That's where another part of big data comes in, which is very, very useful, right? So this is what we call proxy data. So what are proxy data? These are some of the proxy data. You can use mobile data, nightlight, web scraping, keyword searches, audio, video, social media, text. All of these are proxy data. I'll show a couple of examples from this angle, to let you know what we are doing. For example, why mobile data is so useful? Because using mobile data, particularly for countries like Africa, India, Bangladesh, I can differentiate between household. Look at this. We have prepaid customer, right? So a lower household income is going to have more top-up but less amount. A higher household income is going to have good amount of top-up but frequency is low. Just by top-up frequency and amount, I can differentiate between households. A lower socioeconomic level has very less number of people on a both-way network, where he get a call from the same person he calls. But a higher socioeconomic level, you get more both-way networks. These are extremely behavioral in nature, manifested by data. Can I use this data to answer some policy question? That's the key of big data, right? Nightlight. easily available. You can figure out from nightlight a lot of, now it has been established by the economists that a city's economic empowerment is highly proportional to the amount of nightlight in that city. Okay, so that's one angle. So this is, I just thought of introducing big data. Then comes the predictive analytics. Generally in predictive analytics, we know a lot about these 4 things, which is pretty much in these algorithms. I'm not going in detail. However, these are just 10% of the thing. We need better ML. And these are the set of ML came up, which we practically don't know anything yet. So down the road, if you talk to any guy who is doing AI, he will keep on throwing terms like deep learning, reinforcement learning, but we still don't know what these are, why this works, why this converges. These are still a black box to us. Extreme amount of multi-layered neural network. Neural network has been in 1960s, still nobody could prove why it converges, why it works. It just works. It's an algorithm which works. And there are a lot of times which it doesn't work because there is no theoretical basis to it. So we need to put a lot of effort as a researcher. That is where I come, industry academia collaboration, because an industry who has a nice case where they want to use, let's say, deep learning, reinforcement learning, or capsule network, an academia who may have some idea but doesn't have that case, can they come together? They are going to fail, by the way, because there is a lot of unknown territory. You have to give them space to fail and learn. Okay? These are, majority of these algorithms came up last 1 or 2 years. People are trying to figure out what they are, they still don't know. And in my experience, when my student asks what is deep learning, my answer is I really don't know. I use it, but I don't know what it is. Okay? It's a lot of black boxing. And unless these algorithms become, lot of research happens, which just happened just 2-3 years back, AI is a far way to go, the way it can scare us. Now let me skip some of these things. And this is what I feel, that humans plus computer is where, now why human is such a critical element in AI, where everybody is talking about AI is going to scare you. That's because computer still doesn't know how to mimic your behavior. So if you look at these, big data we know a lot, analytics I'm pretty sure we are going to make a lot of move. Behavior, computer scientists has no clue what is human behavior. They don't work with them. Economists understand, but they don't know how to scale it. Okay, they will do some random sampling, they don't know how to scale it. So this is where this interdisciplinary nature coming in. A computer scientist, statistician, economist has to come together, then only it works. Otherwise it doesn't work. Because everybody has, see if I write an algorithm, I don't know how to scale it, but the computer scientist knows. But computer scientist doesn't know why I wrote that algorithm from a behavioral angle. So that needs to come in. So with that, I'll come to the example. So I'll go through a couple of examples which we did using big data, using proxy data, which are very helpful. So there is the first one. So in any country, inflation get estimated at the end of 3 months, every quarter, right? But if you ask a policymaker, a central banker, a commercial banker, it is actually nice if I get that trend, if not exact value, daily. Because they can figure out where market trend is going, they can position themselves before things are out of their hand, they can figure out. But obviously, I do not have data. If I have data officially, I would have calculated it already. I do not have data. So how can I figure out inflation trend even when I do not have data? So this is what we call the billion prices project, right? Because we scrap billion products every day. So basically, these are some of the papers came out where we shown this, some of the economics paper in AER and other places. What we did is as follows. You can use a simple web scraping technology. It is very, day-to-day stuff now, but it was not back in 5 years when we did it. You can actually scrap all of this and get the information of date, item, price description daily for every product available online. Can you calculate inflation from there? Actually, you can. You can see the trend is exactly similar. Again, big data is correlation, not exact. It's a trend. For all the countries we calculated, right now we produce this for 22 countries, including India. And it's all available online. If you go to Google and write billionpricesproject.com, it comes, the code and everything is online. This was funded when I was in US by International Monetary Fund, and it's still going on. So that's one example I wanted to show. Second example is like we did in Sri Lanka, because Sri Lanka's main issue was when LTT came down, Jaffna was a very poor place, a lot of people were migrating to the south of Colombo, and they wanted to know how to put the bus routes and all those things in those places, right? But they don't have data to figure out who are these local migration people who are coming from suburbs and going back in the evening. So what you can do, you can look at the mobile network data, and you can go to two things. One, tie up with the mobile companies and count from every suburb how many people, mobile numbers are moving to that city, staying there, going back in the evening, and what is more important, the same movement by these mobile numbers are not happening in the weekend. If you do that, you get a net number of local migration happening to the city. Not only that, based on the amount of top-up, you can even figure out formal, informal employment. So this was, we did in Sri Lanka, we have started this in Bombay also. Here is another one, and then I'll just use one more, and then I think I'll be done. So can we develop a high frequency policy uncertainty index, which is like a lot of the times government comes up with policies, and it is for the government to understand how my people are reacting to those policies. Are they very uncertain about it, or they don't care at all, right? How can I figure out something which is repetitive in nature, in the sense I can do this exercise again and again, and I don't need to spend a lot of money in creating the data, right? So we tried to develop this using something called high frequency policy uncertainty index. Our hypothesis is very simple. If there is a policy for which my countrymen are extremely uncertain, the newspapers are going to follow this news much longer, more in the front page, and based on the adjectives used, I can figure out whether they're positively shocked or negatively shocked, right? So again, this paper came out in Quarterly Journal of Economics. So this is what we did in US data, and see what? Whenever the uncertainty index is high, something happened to the economy, and the people were uncertain. Not only that, this even tells you what they're uncertain about from the sentences get used. So if you divide the US before 2008, after 2008, people are more uncertain about taxes and healthcare than the usual thing of national security, because after 2008, the taxes had gone up. We did that for India also, and you can see wherever the policy uncertainty index is high, something happened. That means this hypothesis works. But it's a very simple hypothesis, right? The data is already out there. The newspaper comes in the night. You can easily scrap this data, do text analytics, and figure out whether a policy change by the government is making my countrymen more uncertain in thinking about that policy or not. I'll just go to the last one. Sorry, this is the last one. GST. So this is one of my favorite actually. So initially when GST rolled out, conceptually all the checkposts should have been demolished or they should be stopped. And there's a lot of complaint coming to the Transport Secretary that it's actually not happening. And whenever he's sending some inspector, you know how it works. So he was looking for a solution which is, there is no human intervention. So we thought of that what can be the hypothesis to solve this. So hypothesis we came up with that if there is an establishment at the checkpost that has its own light, and if the checkpost is there, the trucks are going to stop and they are contributing to that light. So obviously, if the checkpost is gone, the amount of night light before the GST and after GST, there should be a difference, and after GST, it should go down. That was the hypothesis. We took ISRO data, used image analytics, and tried to see whether this works or not. So here is one. We did pre-post, the night light didn't go down. So we initially thought probably our hypothesis is wrong. So we took another one. Didn't go down. So before I make my case that probably my hypothesis was wrong, I took another one. And it's good because this is my state right now, I live there, so I took a Karnataka one. It actually gone down. So I was going in the direction my hypothesis is right, but I needed a counterfactual. In the sense, I also need to show somewhere where GST was not implemented, and as per my hypothesis, night light should not go down, or the other way around. So we looked at India-Bangladesh border. GST was not implemented, took the night light, it did not go down. So the hypothesis was right. So right now, Department of Transport, Government of India with ISRO, they are developing a dashboard to have every checkpost, every night light on the dashboard coming with this graph. And that's an easy way of checking the fraud without any human intervention. So I'll stop here as I think I have exhausted my allotted time. So I'll stop here and give it to two other panelists. Dr. Jayaraman to take over.
A very good afternoon. This topic of big data and technology is a topic which is very near and dear to me. So there are going to be times during my presentation my voice might go up. I might increase my decibel level, only because I get excited about these topics. So a lot has been said and published about big data. So someone asked me in a previous conference, how would you define big data in a very layman's language? And here's my take on this. My dear colleagues out here can agree or disagree. My response was, for any typical organization, when they reach a point where the amount of data they have to process is beyond their power, computing power, whatever power you want to call, for that organization, that is big data. Think about it, right? If the company reaches a point where they're not able to process this, not able to analyze it, that's that point they reach where they need help, right? So in that sense, there's been some radical shift in terms of how we do business, how customers now have a lot more power, how a company like Amazon is perhaps seizing the so-called center store concept. They have a beautiful project called Project Everest in India, where they changed the way you're going to be doing grocery business. And some of us, including Dr. Ghosh, who has spent many years in the US, we have amazing examples of retail giants who are able to predict with 100% certainty in terms of customer wants and needs. I'll talk about some of my own experience, some of my own research studies on that. But the point I'm trying to make is that we're talking about supply chains across industries for really moving from what I call as near real-time to what we call as real-time data, and perhaps from inside out to inside outside in processes. I'll talk more about it as we make some progress. I want to show you guys a couple of examples of companies that we're very familiar with. Starbucks. Way back, Starbucks did it right in the sense they introduced this concept called as customer loyalty. So back in 2009, many of us who go to Starbucks will have this loyalty card. All you got to do is go into Starbucks. The second you walk into Starbucks and you scan the card, the barista behind knows exactly what you ordered the previous time. You don't have, there's no cash transaction out here. Everything is already stored in their system, and they were able to quickly process customer orders, and you walk out. There's no need to use the credit card or whatnot. Land's End did it wrong because their whole idea of trying to look at customer data was you have to download pretty much all the catalog content, which means now you become very dependent on Wi-Fi access and pretty much rely on a carrier to do the download, right? Several classic examples of companies which were what I call as yesterday's winners: Blockbuster, Nokia, Kodak, Britannica. How many of us can take a lot of pride in having a series of Britannica dictionaries at home? Those red-bounded, golden-framed, golden-colored Britannica at home. Where are they now? Britannica published the very last version way back in 2012, right? So these days, it's about Netflix or Apple or Google or Wikipedia has taken over, where it is pretty much free. It is real-time updated information. Of course, there's always a question about whether the information is correct or not. But the fact is, they're able to give customers access to the information real time, right? So it's all about the age of information and the age of the consumer. In the past, it was all about business requirements, which used to drive technology as a key enabler. Now, pretty much customers are dictating how you have to run your business, what you can offer, and in fact, to a large extent, what price you're going to charge. So my point is, going digital these days is no longer, it's no longer a question out here. It's no longer an option out here. It's pretty much the default, so to speak. Whether we're talking about digital natives like Amazon or Uber or Ola, or digital immigrants like Walmart, it's about how we can use disruption, how we can use technology as an enabler, but understand that going digital is pretty much a way to access this data and are able to do all kinds of analysis to provide meaningful results. I have an example of 8 companies out here, and what is very interesting is that, for example, Uber claims to be the world's largest taxi company. We all know they don't own any taxis. B&B claims to have the world's largest number of beds. Guess what? They own no beds. So there are 8 examples I have on the slide, but I want you guys to keep in mind, 7 of these companies did not even exist 20 years ago. Okay? So my point is this disruption. It needs a platform. It has to have a way to actually provide some useful insights. So to me, technology is not just an enabling function, but technology was actually a supporting function many years ago. Now it is pretty much going to be an enabling function, and I call this my pyramid model that we have used in some of our research and case studies, where we are showing that in the 3 corners of the triangle, you have the company, the employees, the customer. We put technology right in the middle of the triangle to pretty much make the case that this is going to be a pretty interesting way to enable how to do business, so to speak. So to me, it's a game changer, whether we're talking about AI, whether we're talking about AR, talking about blockchains, we're talking about IoT, we're talking about 3D printing. All these are going to be game changers, and I'll talk about a couple of case studies, a couple of my own consulting work in some of these areas, but it's pretty much taken over in terms of how to use technology to do business. And I'm not going to get into defining what is blockchain. I'm not going to get into defining what is IoT. But what is very interesting is there is a lot of forecasts which says by 2020, we are going to have at least 4 billion people who are going to be connected, who are all going to be about $4 trillion revenue. There are going to be close to about 25 million apps and 25 billion embedded systems and about at least about 30 zettabytes of data, which I think is a very interesting way to look at how to do business. But this is facts, these are data that we are able to pick up. This pretty much takes me to what is going on now. So one of the things we have done extensively in Great Lakes is to focus on how to use the technology. So the acronym I coined is AIMLA, which pretty much stands for AI, MLA, Artificial Intelligence, Machine Learning, and Algorithmic Analytics, where what we're able to show to companies, what we're able to convey to our students, what we're able to teach in the classroom, and what we're able to convey in terms of research is, it's no longer about traditional programming. It's not about using today's data and today's algorithm to look at today's output. It's about using today's data and using yesterday's output to bring in all kinds of machine learning algorithms to provide what's going to happen in the future. It's all about using data to predict what's going to happen in the future, right? So that's what I mean by the whole idea of data analysis. And to me, data is the king. 90% of global data that the world wants today was pretty much created in the last maybe 10, 15 years. And 90% of the major data storage, processing, and dissemination platform came into existence in the last maybe dozen years. So if you go way back to 2004, LinkedIn was just 1 year old. Facebook was just born. Okay, Great Lakes was obviously born in 2004. Twitter was 2 years away. The first iPhone was 3 years away. All this talk about cloud was 5 years away. The first iPad was 6 years away, right? So the point is, it's a very young subject. But having said that, it's also important to understand how we have made progress in time to the point where in this 21st century, data indeed, whether it's big data or data per se, indeed is the key driver to look at how to do all these analytics and data sciences, right? So to me, I mean, obviously data is a new oil, and it's about having a way, it's pretty valuable, but it is still in a very unstructured, very undefined form. It's up to us as researchers, as consultants, as industry participants to find a way to use the right kind of data to provide the right kind of analysis, so to speak. So to me, big data pretty much embodies very new data characteristics which are created by today's what I call as marketplace, which is digitized, whether we're talking about volume, variety, velocity, or perhaps even veracity of information. It's all about trying to understand data in terms of scalability, data in terms of form, structured, unstructured, data in terms of motion, if you will, and perhaps data in terms of uncertainty, the veracity part I was talking about, right? So in terms of what does it do to policy implication, and I'm going to build upon a lot of what Dr. Ghosh has spoken about, how big data in terms of policy purposes, how it can be a source of very interesting information, and perhaps what I call as intelligence that are being gathered from a recorded action, or perhaps a combination of records, whether we're looking at supermarkets. Now people, we have the ability to, if there are supermarkets where when you walk into an aisle, you're suddenly getting a ping in your smartphone which talks about, let's say you're walking into an aisle where there are breakfast cereal. You get an instant ping which tells, okay, if you're going to buy the cereal today, it comes with 20% discount. I'm building up on what Dr. Ghosh spoke about. It's not even 30 minutes away. We're talking about real time. You're walking through the aisle, you're getting the ping where the manufacturer and the retailer are promoting this product. They say, if you buy the product today, it comes with a discount. I mean, that is the power of information. So in terms of supermarket purchases, in terms of robots, information, telephone operators, I can go on social media, speech and word recognition, text analytics, the list seems endless as more and more information becomes perhaps public and digital, right? So that comes to the question of the term big data. I said it has a variety of interpretation. So big data to me is not just about large data sets. It's not just about the 4 V's we're talking about, but it's also about how we're going to be using the data to provide those useful insights that companies can actually put into place and take forward, right? So I want to quickly describe the big data approach to analytics that we discuss a lot in the classrooms. We discuss a lot in terms of with our industry partners. If you look at traditional analytics, right, it's pretty much structured and perhaps repeatable structure to store data. So you have a set of hypotheses that all of us as researchers are guilty of. We propose a hypothesis, we go out, we get some data, whether it's going to be primary survey data or secondary data from industries, and then based on the analysis, we're going to either support or not support certain hypotheses, and we provide some implication, right? Great. Now, there has been a shift out here where instead of trying to start with hypothesis against selected data, why can't we have the data lead the way to help us explore, pretty much ways by which we can do the analysis, identify correlation. So let's take the data, let's do the exploration, okay? Then look for patterns, correlations and whatnot, and then look at insights which are actionable, right? So data should lead the way, so it's going to help us explore or identify correlations or whatnot. So my point is, instead of trying to analyze after landing, so to speak, why can't we analyze while it's in motion, right? So that's the whole funda behind the big data approach that we're proposing in our classrooms. So to me, big data is just a beginning. I mean, in terms of how things have happened the last decade or so, this gives us a good way to take this. And to me, it's a game changer, where we are competing on not just data, not just information, not just knowledge, not just on technology convergence, not just on design innovation, but also competing on analytics to provide us useful insights, right? So yesterday's analytics was more about experience. It's more about how do you go from descriptive to diagnostic, if you will. It is all based on, not all, a lot based on what I call as hindsight. Today's analytics is more experimental, where there's been a shift from diagnostic to predictive, if you will, but there's a very healthy mix of lag and lead data. It is our belief, based on our own research and talking to companies, that tomorrow's analytics is about expectation. It's trying to transform or move from prediction or predictive to what I call as prescriptive, where the lead data is based on a lot of foresight, not just on hindsight, but lost on foresight, right? So I'm going to talk a little bit about a big paradigm shift in terms of how to deal with market space, okay? So the old approach, if you will, was products design in a lab, where looking at a lot of design. The new approach is based on market research, based on market-driven research design. I mean, I can give you many examples of, if you think about insurance, there is this beautiful shift happened the last decade or so, where it's not about selling fear, but selling hope, right? Take the example of the move. It was trying to identify back pain was a MR brainwave, so to speak. Talk about noodles and pizza, right? Shift from evening snacks to actually dinner, putting them on dinner table. So I think that approach is something which we need to recognize. The second paradigm shift in terms of old approach was monologue. And to me, I think there's only one way, whether it's radio, television, hoardings, newspapers, magazines, and whatnot. Now it's about dialogue. Let's sit down, talk about it. Let's have blogs. Let's have forums. Let's tweet. Let's have call center live chats. Let's dialogue. Let's talk, and as well as listen and look at how to do the analysis. The third paradigm shift, again, is moving from what I call as transactional to what I call as customer lifetime relationship, right? The so-called holistic approach, and that's what we're seeing in more retail companies. Airline industry is very, very famous for that. We are seeing a lot more now in the healthcare industry with how they maintain the patient record management system. With healthcare, there are some projects we're doing in hospitals where from the second the patient walks in the hospital to the point the patient is going to leave the hospital, everything gets tracked and everything gets stored to the point where sometimes there's no need for the patient to actually go to the hospital physically. A lot of these things can be done offline just with having data available to us. The fourth paradigm shift is moving from what I call as a very rigid and inflexible supply chain to what I call as a very flexible hybrid supply chain, where you still have the e-commerce initiatives, you still have the value-added resellers, you still have direct selling, but it's all supported by what I call as a normal channels approach. The fifth paradigm shift is in moving from what I call as devices that are standalone to pretty much new approach where we're going to have devices which are converging, right? Converging the last mile, perhaps. A lot of work has been done on the last mile system. And finally, there's a paradigm shift, I believe, in looking at how to take this information forward. So folks, I want to talk about a couple of questions, and please alert me when, we're all professors, you put us in front of a mic, we forget ourselves, so you have to alert me in terms of time, sir. Imagine if you had all the answers. Imagine if you know which customers are going to think of leaving you. Imagine if you know which transactions are fraudulent. Imagine which new product has the greatest chance of success. And how can you extract insight? Okay? These are very, very interesting questions, but guess what? A lot of us, a lot of researchers, a lot of industry people are actually doing work on this. So to give you an example, we now have a system in place. It's taken us almost 2.5, 3 years to work on this. We now have a system in place where for some of our programs, we are able to actually predict which of our students are going to not finish the program on time. How many of our students need help? How many of our students need help where? So we're able to, by using very sophisticated algorithms, machine learning algorithms, we're able to predict this with almost a 90% accuracy. And if you have the right amount of intervention, we are able to pretty much convince many of these students to stay back in the program. And in fact, many of them are doing quite well now in terms of the jobs, right? So I think it's important that to us, the ultimate differentiator today is being able to make much more what I call as informed choices with confidence, but more important to anticipate, to predict, and shape our business outcomes, right? So this is all about customer churn, people. It's all about trying to enhance customer understanding, and all about understanding why do people leave and how can I intervene. So in our case, happen to be students, but in case of companies, could be customers. If we can have these algorithms, which are going to be using data, of course, are able to predict. So this is where we talk about customer analytics. We talk about predictive analytics. We talk about master data management, big data, warehouse scalability. If we're able to use all these models that we can build, all these algorithms, and are able to pretty much understand or intervene at the right time, I think it'll really, really be helpful in the long future in terms of having a direct correlation to a company's ROI or profitability or whatnot. So this is all about supply chain visibility. I mean, the entire, when I say visibility, is of course the entire supply chain, all the way start from the sourcing point to the retail point. How can I make informed decisions at the point of impact? And now we have lots of case studies which shows us that this has a direct effect on a company's ROI by having the supply chain visibility. And it also helps us provide some steps in terms of understanding customer experience and trying to understand it's not time value of money, people. It's about what I call as money value of time. Very important. Your time is precious. So what is the money value of time in terms of understanding customer requirements? And you have to understand what to measure, because measuring what matters, that what matters most to customers, because customers care about outcomes. Customers care about, you providing the so-called seamless experience across channels and touch points. So imagine the possibility in a world with no limits, where there's information coming from everywhere. There is radical flexibility in terms of how you look at data, and extreme scalability. Now, it's not just for textbook. We are able to now, there are lots of people working on these issues where they're looking at organizations, where they're able to use business analytics, where they're able to provide optimization or optimal control theory as a way to provide how to enhance customer understanding, how to optimize not just decisions, but optimize real-time decisions, and perhaps also foster collaborative processes to build what I call as a efficient information management foundation. And we have data, I have data across automotive industry, healthcare manufacturers, and financial services. Shows us that organizations that embrace such techniques have the answers, or some of the answers they required to outperform the competition. I mean, that's now data very clear to us in terms of the output. So the time to act is now, where you have the so-called convergence of market force and technology that is pretty much widening the gap between the so-called leaders and the so-called laggards, and trying to look at this with achieving globability, where we're able to compete with anyone, compete anywhere, compete for any resource in the world, and we can pretty much look at globalization. I'm not going to bore you with all these machine learning techniques, but these are techniques now that many researchers actually put into place, where we're taking some of the existing machine learning techniques, but are able to pretty much adapt and adopt some interesting algorithms and applying them to many use cases across multiple industries. The one example I want to talk to you guys before I leave is the automotive industry, where I've been very familiar last 10, 12 years, been working in this area. What is very interesting about automotive industry is look at where we were way back in the 1960s to where we are today. I mean, just the experience that you have in your car, when you sit in the car, has totally changed over the period of time. And so what I call as system innovation, as opposed to just single innovation, where we're now talking about heat glasses and DVDs and keyless entry and whatnot. But what is very interesting in the auto industry is, who's going to drive you home? Now, one of the panel discussion we had in the morning, talked about how more and more people, and I'm again talking about data that we picked up from the US, where what is so scary is we're talking about very young people, somewhere within the 25 to 35 age group. I don't know, many of us didn't predict this, but it reached a point where most of them are happy to actually pick up a Uber or Ola. They would rather not drive. They're able to carpool, right? So in terms of how to use, so here's an example where, whether you're talking about IoT or AI space, is the auto industry, I believe, on the brink of revolution? Perhaps we look at what happened years ago to where we are today, where we are going to go in terms of 2020. So the whole idea of Tesla, the self-driving initiatives, I think Mr. Mohandas Pai talked about this whole idea of IC versus electric vehicles. So is it going to be IoT kind of car of tomorrow? Or are we talking about, so Gartner predicts by 2020, more than 250 million vehicles will be connected globally. And the number of installed units will increase by almost 65%. I mean, that's a very scary thought, but then look at the experience you have, or you are having when you sit in your car today, to what I'm sure your parents would have had 20, 30 years ago. So to me, all conclusions are temporary. The clock speeds are increasing almost everywhere, and the value chain design and service system design are key competencies. And if you go back and look at the fruit fly, it's a very interesting example. A lot of work is done, or study of fruit flies can help with crafting a strategy. So I'll reserve the questions later on, but I'm pretty much done for now. Thank you.
Okay. Let me just keep. Good afternoon, everybody. Thank you for the opportunity to be part of this discussion. And it's really wonderful to hear the professors and hear the research mindset around such a very important problem. So I'm going to come at it from a different point of view, which is a practitioner's point of view. I've had the good fortune of being in the US and working there for about 16 years or so, and now back in India for another 16 years or so. And I must tell you that in the first experience, we didn't really use data a whole lot. At that point in time, I recall very fondly, FTP was big, Mosaic was coming along, Netscape just got formed, Microsoft suddenly realized they needed Internet Explorer. Internet was just beginning. But by the time I landed up in India, early 2000s, the world had changed. So what I'd like to share with you is an industry point of view, a point of view of what do practitioners look at when we are building companies. I happen to have had the opportunity to roll out the technology platforms of all the industries I'm going to talk about. And therefore, as academia, what are some of the things that you will learn from us as practitioners are actually how we look at the problem, and perhaps you can come about with solutions which will help us get to the answers. I'm just going to use 2 slides. The first one, I'm just going to give you 4 examples, 4 industries that I've been part of over the past approximately 20 years or so, and spanning approximately 20 countries of rollout. So first one, and the first 2, which is telecom and media, it is very interesting. The way I look at it today It's been nothing but a confluence of communication, content, and commerce, all coming together, all within the substrate of a context. And what I've discovered and what I've understood over this past journey in these two industries is context was missing significantly. And where big data will play a huge role is to bring in context into each one of these experiences. So let me start with telecom. In each of these quadrants, you'll see that, or sectors, you'll see that I've simplified the disruption that's happening in that industry. So telecom industry, we went through a massive revolution. It was voice, it became data, and now it's content. And commerce is just around the corner. So that industry has fundamentally changed. And I remember the platforms that we had to roll out. So we were dealing with billions of data records every day. And we had to be worried about the system topology because I was responsible for rolling it out for 20 countries. And when you have data coming from 20 countries, you cannot centralize them all simply because there are data privacy laws in various countries, especially countries in Africa, which have got very, very strict policies and so on and so forth. Not that India does not. India does as well. And so when you're dealing with billions and billions of data points, and you're dealing with regulation and topology that is dictated by these policies, you realize that you got to solve some rather large systems issues to simply get the data. Only if you get the data can you do a big data analysis around it. And some of the challenges we had to really overcome and the problems we had to solve were around revenue assurance and fraud management. These are very, very tricky. There were tons of frauds in the industry over the past 10 years or so. And a fraud means a call made where you don't pay for it, or an internet experience where the customer does not pay for it. At the end of the day is loss of revenue to the operator, which I was part of. How do you detect frauds? Worst case, the even more tricky situation was when your SIM card is used to trigger off an unfortunate explosion somewhere. How do you check that? How do you check for these very, very serious issues related to terrorist activities and so on and so forth? There are frauds because we had, and I ran customer service for this company as well. I had 45,000 call center agents working in my organization. Somewhere if there's a leak, somewhere, some information is known, subscriber data is revealed, and temporarily the SIM card is switched over from a legitimate phone device to an IED device where it triggers off an explosion. You've got to look out for that data. So these are real problems we have to solve. So revenue assurance, fraud management, looking at customer data, and churn prediction, which was something that was mentioned earlier as well. How do we know when a customer is about to churn? So while we were adding on, let's say 10 to 12 or 13 million subscribers every month, 2 or 3 million subscribers would churn out. And this was a time when there were many operators in the country, 8, 9, 10 telecom operators in the country. Obviously, there was a structural, I wouldn't like to call it defect, but there was a structural peculiarity in the telecom industry at that point in time. Of course, there's a lot of consolidation happening right now. So in that situation, the role of data becomes extremely important. And then came the apps, and then came content, and then came 3G, 4G, all these networks. And then it was very important to understand what products do you recommend to the customers? How do you recommend pricing plans? How do you choose or show the kind of data that the customer is interested in? If he or she went to a cricket site, how do you make sure that the next time he comes around, you proposition something around cricket? So in the telecom industry, big data started playing a very important role almost 10 years back. And today, I tell you, there's a very, very significant role there. I'm not part of that industry right now, but yes, there is a whole amount of work that's going on, fundamentally because that industry has transformed more and more, not just as a data pipe industry, but more as a content provider and soon a commerce place. It's really a marketplace as you see how the industry is evolving. Next, I've had the good fortune of spending nearly 5 years or so in the media industry. This was a mix of both traditional media. So I was, as the CTO, I was rolling out systems for publishing newspapers, very popular newspapers in India, as well as their digital counterparts, so the online sites, so to speak. Now, obviously, in the traditional space, we needed to understand readers who read the newspapers, or listeners. We had multiple radio channels in many cities in the country. So how do you understand who the listeners are? What is the engagement time? How do you understand who your readers are? And then try and correlate it with what their online activity might be. And online activity, there's a lot of work that went on to collect first-party data and third-party data. First-party data is pretty much what the reader or the subscriber would offer on his or her own volition and consent. Third-party is what you pick up from different sources, and you need to start mashing them together and making some sense out of it. And then look at content and content consumption, because this whole industry is about engagement. It's about eyeballs. It's about, therefore, monetizing through advertisements or possibly commerce. So understanding context, understanding engagement, and understanding content consumption behavior became a very, very, very difficult and an important and an interesting problem to solve. And that's something that I've been just until very recently working on. And also deciding what kinds of content to put out there. So there's a typical testing called A/B testing, where you put out articles with different titles online, and you start testing which of the titles are more appealing to what kinds of audience and in which segment, what age groups, et cetera, which IP addresses, which parts of India, which parts of the world, because it's online. So there's a lot of work where big data started playing a very, very important role in the media industry and the telecom industry. And the first two industries, like I had mentioned, is truly a confluence of communication, content, and a fair amount of commerce kicking in. And today, most of the systems that we are building out have got a huge amount of context built into it. Where are you? What time of day it is? Who's your social graph? What's your social network? All of that is coming in. Then, very recently, I started doing some work in the infrastructure space, which is very, very different. Few years. We've been rolling out smart infrastructure. These are infrastructure for smart cities and infrastructure for solar deployments. Now, these are CapEx-intensive deployments. Started plugging in a lot of IoT on this. A lot of sensors started coming on this. And when you start plugging in a lot of IoT on it, you're getting dribs and drabs of data coming in. So, for example, a smart pole is a combination of a network. So it has got a mobile network, it has got a Wi-Fi network, it has got lighting, it has got environmental sensors, it has got large video display screens, it has got video cameras, it has got panic buttons, and it has got a power source that is beneath the ground, and it's all water resistant, and we ship it to about 20 countries or so. And these are world-class things that are built. All of these are producing data. And when you have poles that are interspersed through the city at a certain granularity and frequency and vigor, when you've got eyes watching them, video analytics, and you can sense what to do with traffic, then it's a very large big data problem that needs to be solved, especially when you need to look for miscreants or untold or sort of unfortunate incidents that might happen in some parts of the city. So in the infrastructure space, the fundamental disruption that's happening in the industry is moving from passive infrastructure to smart infrastructure. And that is happening today. You see some of it around, but you'll see more and more coming out. And so the problem I'd like to submit is how do you deal with extremely high volumes of data coming in? From a computational perspective, we are talking of real-time ETL, extract, transform, load. So when you have to deal with highly distributed points of presence, you've got a choppy network, and you've got little dribs and drabs of data coming in. How do you actually make sense of it? Because there's a timestamp associated with each data packet that comes in. These may not be very big. The payload may be just a few bytes or a few kilobytes. So I'm not talking of megabytes or gigabytes of data coming in, but you still need to manage it. And we have found that some of the biggies these days, the cloud providers, are coming up with very interesting platforms that are relevant to us. wherein you can ingest this data in a near real-time ETL form, because you will get an interleaved or a mix of batch mode and real-time data coming in, and all of that has to be brought together. And we are finding that we're also applying it in the solar case right now. We got a bunch of solar deployments. And what happens is, if you can collect all the data and analyze all it, then you can use it for predictive maintenance. Predicting what might happen next. Knowing the weather pattern, you will know that there's probably going to be a dust storm, and hence the solar panel efficiency is going to drop down. If that panel efficiency is going to drop down, then how do you, A, do what is needed before the storm, and more importantly, get somebody out there just in time after the storm so that the efficiency can go up. So predicting what needs to get done becomes extremely important, because when it generates power or electricity, it is a unit wherein it uses solar first, then uses the grid power, then uses diesel generators, and then goes finally to battery, because the SLA of that power plant is 5 nines. With a 5-9 power plant SLA, you really need to use big data in a very significant manner so that you can actually reduce its maintenance costs. And the way you reduce maintenance costs is by analyzing the previous data and forecasting what might happen and start doing some predictive maintenance. Predictive maintenance is a very big field, especially for extremely complex infrastructure. If CapEx is to the tune of billions of dollars, you can imagine the OpEx will be in several $100 million sometimes, or $100 million every year. Can you bring that down to $50 million for any given small company? So those are some of the real economic benefits that you'll get. Of course, not to talk about the benefit of preserving human life if you get it right. I'm very recently getting involved in some financial services things we are setting up, and we are operating in Tier 2 India. In Tier 2 India, it's mobile first. Everything is mobile, so your entire system runs on the mobile. And it's all geo-X, so it's geo-coded, it's geo-fenced, it's geo-tracked, everything. That means everything happens by location, and in the particular type of lending business we are setting in, risk management becomes very important. And to understand the paying capacity of an individual in a village or a semi-urban or a semi-rural part of India, obviously a CIBIL report will not do it. You don't have data sets that can tell you, but yes, there are data sets out there that can look at their mobile expenditure, that can look at how much cash they carry back every day, that can look at who all are there in their friends and family. So a lot of third-party and other data sets starts coming in. So systems we build are highly API-oriented, and they dip into very deep fintech algorithms supported by companies such as Perfios and Hunter and Sherlock and so on and so forth, that know how to do bank statement analysis, that know how to look at electricity consumption in the house. So for example, if you know the guy is willing to pay 5,000 rupees for just to run his electricity in the house, something must be going on there. He may have the ability to borrow. And borrowing and lending is a very, very popular topic in all the newspapers these days today and the news channels today. The use of big data in that economic explosion, where leveraging is hardly taken off in our country, is extremely important and vital, and risk management is extremely important and vital. You hear about NPAs and all of that everywhere. The question is, how do you manage NPA in Tier 2 India? And therein, there's a fundamental and a very important opportunity for the academia to help us with some of those problems. Of course, collections is yet another very, very important part of what needs to get done. So with these 4 examples, I hope I've shared some perspectives on within India and some of the neighboring countries, emerging world countries. You get some of an idea of what practitioners like us have to worry about, thereby how can you all work on algorithms and fundamental ways of helping us. Which brings me to the last slide, which is to say, what does that therefore mean? For a practitioner such as me, or the companies that I build, or the technologies that I run, I'm worried about 5 things. And if you can help me solve one of these 5 or all of these 5, that'll be fantastic. 1, how do I get direct and indirect data, which is first-party and third-party data, in a very efficient manner? That'll be very, very good if I can get that, because I know then you can pump it into algorithms that can solve problems for us. Second, I'll be happy with near real-time data. We spoke about real-time. I'll be happy. I know that the deployments that I'm working on have got tons of sensors. There are problems that sensors have to deal with. Sensors may go offline. Sensors have power issues. Sensors may get spoiled in the rain and in the sun. There are individual problems there for sensors. Network payload becomes a problem. Security becomes a problem. Man-in-the-middle attack becomes a problem. So these are real problems on how to get them in a near real-time manner. Unfortunately, the real industry does not have the luxury of just getting and pumping everything into a back-end server and then processing it. It just doesn't work that way. It is distributed, and it's very difficult to get the data. Third, what will be the systems architecture when we actually deploy? Information lifecycle management becomes very important because there's a cost associated with storing every data element, be it raw data or summary data. What medium do I use to store? A spinning disk or a flash storage or a tape? In the telecom industry, you know we have to store data by regulation for 10 years or what have you. Where do we store it? There are cost implications. Or do I just poof it? Do I just get rid of it? So we would like very, very good methods to give us economical information lifecycle management. And then there's a technique to deploy it, what I'd like to call as enterprise and internet, E for enterprise, I for internet. I will not get into the details of enterprise and internet, but they're two fundamentally different deployment schemes for technology in large scale or enterprises. So architecture is a very important role. Of course, to get big data going, and for us to use all the first and third party data to come in, topology, our systems topology, our business topology, exactly where our servers sit, do they sit in country, out of the country, are a function of regulation and policy. Data privacy plays a very, very important role. So I know that's a topic right now, but that's something we worry about. For example, when I had to roll out 17 countries in Africa. We made an acquisition, we rolled out those countries. For some, I could collect the data and use my undersea submarine cable and bring the data to Pune. For some, I had to use VSATs and pump it through London back in. But for many, I had to keep them on-prem, not on-prem, in-country. And that changes my cost structure. So it changes my topology. It also changes my response time. So topology is a very, very important thing. And finally, with all this big data happening and with AI and ML algorithms working, we really need two things. We need very powerful visualization so that we can interact with the data for decisioning. So the human part of decisioning is extremely important. And I know there are tools coming out which help with good visualization, but I think visualization is going to play a very, very important role, far more than we imagine it to be. Because at the end of the day, the human mind, as they interplay with data, might discover patterns that might not be algorithmically discoverable. So that's an important role, and I think the academia can continue to help and work with that. And of course, decisioning. Whether it's analytics or prediction, and some of the other frameworks that were put forward around foresight and so on and so forth, we would really love to get much better decisioning capabilities. Whether it is inputs and outputs resulting in new algorithms that come out, some of those things that were mentioned earlier. We like the direction in which you all are thinking. We'd like to then see that come into fruition. But let me tell you, we're not going to be able to just hand it over to the machine, especially in critical industries like telecom, which is critical infrastructure, financial services. Even media, because fake news is a very, very important thing, and it has a direct implication on our brand and how we used to deal with content. So I hope with these 5 points, I've given you an outside-in perspective, to just borrow a term, so that is relevant to this audience. And I'm looking forward to a lot of good work that comes out of it, and hopefully use it in my financial services venture now. Thank you very much for the opportunity.